Okay, so we're going to do two examples in this video simplifying the radical expression. One thing that we need to recognize is that if we follow order of operations, and I'm not a big fan of using PEMDAS, it's great when you're in elementary school. It excludes the whole idea of missing pieces of moving left to right. Multiplication only happens before division if it's on the left. The other issue is that it doesn't talk about radicals and those types of things. So radicals, and they're exponents, just in a different format. So we know that we have multiplication here, but because of the radical and the power on the outside, I am actually working with, a radical exponent. So, for lack of a better term. Now, the power, I'm going to write this as a fraction because I think this is a little bit easier to understand how we can write this as a fraction to kind of make the because this is a fourth root. So what number times itself 4 times is equal to 625? Well, if you know that, great. If not, an easier way to work with this is to understand that the exponent, and this is our numerator in our fraction, and this guy is our denominator. So I could rewrite 625 to the 2/4, which is equal to 2 times 625 to the 1/2. Okay, well, what's 625 to the 1/2? Well, that's the same as the square root. Anything to the 1/2 is the same as the square root of the number because it's 625 to the first and the root is a second root. So it's a square root. So this makes it much easier to work with, and we should know that the square root of 625 is 25. And so without using a calculator, we get to our solution, which is 50. Now as we look at the second example, we have, sorry, let me erase that real quick. With the second example, we have quite a bit going on here, and we also have a negative value inside the radical. So a little side work here. Roots are telling us what number times itself, x many times is equal to the number on the inside. So the idea here is what number by itself 3 times is going to equal negative 125. We're so used to not being able to take the square root of a negative number because two numbers that are the same multiplied together would never equal a negative 4. But when it comes to 3 numbers multiplied together, we can get negative values. So when the radical is odd, negative numbers are fine. They'll work out mathematically. We can show that it works. So we can either look at the cube root of negative 125 and think about it in our head. If we have our calculator, the easiest way to do it on your calculator, and I'll show a separate video on how to do this, we just raise it to the 1/3, and that'll give us our answer. But let's say we don't have our calculator. We could use basic factor trees. I know that's, and what I do is I ignore the negative because I know it's going to be a negative value. So 25 times, well, you don't necessarily need to, times negative 5 is 125. Positive 25 is the same as negative 5 times negative 5. And because it is a cube root, we're going to look for a group, or I should say a set of 3 numbers that are the same. What 3 numbers that are the same multiplied together will equal negative 125, and that's negative 5. So a lot of times if we think about, hey, it's positive, and then we just know to make it negative. So I work with the radical first. It is an exponent, so that gives me, I don't know why I wrote negative 8. That gives me my value of negative 5, so that's reduced. I have a negative next to a negative, so that's going to make it positive, and the 5's cancel out. So I have 2 minus 3, and this would reduce or simplify to negative 1. So that's how we can work with radicals and simplify them. And going forward, we're going to do more with function work.